So here today we discuss AC voltage applied on inductor. Okay, in previous class we discussed AC voltage applied on a resistor. Here we discuss AC voltage applied on inductor. Applied on inductor. And keep in mind, in previous class we discussed AC voltage applied on a resistor. Resistor and inductor both are passive component, but there is a difference. Okay, resistor is a independent of frequency, and but inductor and capacitor both are dependent on frequency. Okay, both are dependent on frequency. They are the independent of frequency. Okay, resistor. Keep in mind. Okay, so here AC voltage applied on inductor. Now we choose AC source, AC voltage source. There is a inductor are in series. As a L, and that's the EMF. So here EMF means a potential. That's the AC. That is V equal to Vm sine omega t. Now applying KVL here. Applying KVL. Kirchhoff's voltage law here. Now, the EMF is a function of time because that is a V equal to Vm sine omega t. That is a function of time. That is EMF is a function of t. That is potential drop across inductor is a L di dt. Okay, so EMF t means here that is equal to Vm sine omega t L di dt. Now di dt that is equal to Vm by L sine omega t. Okay, so keep in mind there is a Vm by L. Okay, so there is a constant. Okay, in a previous class, that is we get that, if you remember that the previous class we get that is I equal to Vm by R sine omega t, and here we get di dt Vm by L sine omega t. Now integrate both sides. Okay, so if I integrate both sides, di that is a Vm by L sine omega t dt. So the integration, after integration, di get I Vm by L. Integration of sine means minus cos omega t by omega. So that is equal to I equal to Vm minus obviously L cos omega t. Okay, so there is a minus sign. Okay, and we compare these, that is a Vm sine function here, and that's a cos function. So now change it. Okay, and we know that sine pi by 2 90 degree minus theta, that is equal to cos theta. Okay, and now take a common of minus here, minus sine theta minus pi by 2. Okay, that is equal to cos theta. So means this minus remove from here, put here, this both are be the same. Okay, so now that's change these minus sorry, here is omega obviously. Vm by omega L, this cos omega t replaced by minus cos omega t replaced by this now plus, that is sine omega t minus pi by 2, that is I. Okay, so finally we get I equal to Vm by omega L, that's the maximum voltage by omega L sine omega t minus pi by 2. Okay, so now if I compare this from previous expression, okay, that's the maximum current. Okay, that's the maximum current, that is I equal to Im sine omega t minus pi by 2. Okay, so now the Im, that is equal to Vm by omega L. So from Ohm's law, that is V equal to IR, and this omega L, okay, these are that almost look like a resistance, okay, in the circuit. It look like a resistance in a circuit, and this resistance is dependent on frequency. Obviously there is a, and these are inductance, obviously, okay, they depend on frequency. So these are called inductive reactance. This resistance in that circuit is called inductive reactance, and here is a SI will be the ohm. Okay, keep in mind. And these inductive reactance means why? Because they depend on frequency. Because depend on frequency. Here actually we discuss it. Okay, so that's a depend on frequency. Inductor and capacitor both are frequency dependent. Okay, so that is depend on frequency. And this is another name is the inductive reactance. It's called XL. And here XL, that is equal to Im, that is equal to Vm, maximum current, maximum voltage, times XL. And these are the inductive reactance, and SI will be the ohm. Okay, so here the phasor diagram, and you see that V here, consider V equal to Vm sine omega t, and the current here is omega t minus pi by 2. Here the okay, the current is minus pi by 2 or 90-degree lag. Okay, so here is important, both being same, obviously. Okay, the current is lagging by pi by 2. So current is lagging pi by 2. Okay, by pi 2. Our voltage is leading pi by 2. We draw a phasor diagram. Okay, here the current is lagging by pi by 2. Keep in mind. Okay, now draw a diagram look like this. These are draw a phasor diagram. Phasor diagram. Okay, and phasor is a vector. Okay, so voltage phasor, here is the current phasor. Okay, so now diagrams look like this. That's the voltage phasor. These are the voltage, and there is a current, and now that's a pi by 2. That's a pi by 2, and that's a I. Okay, and that's angle with the omega t1, some angle. Okay, and now if I try to draw a phasor diagram, so the maximum voltage here at that point, so there's the maximum voltage here from origin to maximum. This is a voltage diagram. Okay, there's a voltage, and now the current starting from here at that point, current starting from here. Okay, and this look like this. Okay, and now the midpoint, there is a fall, Okay. So now here you see that a full cycle here, one full cycle has a maximum, okay, voltage. So there is a, if I rotate here, so these are that point is a maximum current here. Okay. Okay. So here we see that the V, this voltage V, that's equal to V equal to Vm sine omega t, and I see that I, this current, that is Im sine omega t minus pi by 2. That's is pi by 2 difference between voltage and current. Okay. And now we see that is very carefully, that is a 0 degree here, that's a 0 degree, and that is a pi by 2, when a voltage at pi by 2 is a maximum but current is 0 from negative portion to, okay, and when current is maximum there's a, okay, that's called pi, so voltage being 0, and that is a pi, that is a 3 pi by 2, and that is equal to 2 pi. Clear? That's the full cycle, a full time period, and that's the phasor diagram of when AC voltage applied on inductor. Okay. Now calculate power. Okay, that's the maximum voltage and that's the maximum current. Okay, that's the phasor diagram at that point. Verify at that point. So now you see that is omega t1. Okay, so there's the omega t1 at cutting point here, and here is omega t1 because there's a omega t1 cutting point is here. There's this line is called omega. Okay, this line is omega t1. This cutting point is, okay. So that is okay. The current here, that is I equal to Im sine omega t1 minus pi by 2, and here, okay, that is V equal to Vm sine omega t1. Okay, and in this line, because these are full cycle with the same, obviously. Okay, this line and this line the same. Now keep in mind. Okay, now we calculate a power across load. Now calculate power across load. Power. Okay, so power PL across load, that is equal to I times V, voltage times current, or current times voltage. So here I equal to Im maximum current sine omega t minus pi by 2, and here V equal to Vm sine omega t. Okay, now that is equal to, if I come minus with the common, that is Im sine pi by 2 minus omega t Vm sine omega t. Okay, so minus Im Vm sine omega t, this sine omega t, that is sine pi by 2 minus theta, that is cos theta, so cos omega t. Now that is Im Vm by 2 sine omega t cos omega t, 2 sine theta cos theta, that is equal to sine 2 theta, so minus Im Vm by 2 sine 2 theta means 2 omega t. Okay, now calculate average power. So load power average, okay, PL of average, that is equal to power average, that is equal to minus Im Vm by 2 sine twice omega t here. Okay, and now we calculate the full cycle integration of these. Okay, that is the function of t. Okay, in previous class we solved this. This is a function of t. So full cycle integration. So there is a function of t, that's the full cycle integral, obviously. Okay, keep in mind that the full cycle integral, that is a mean, the bar representation is mean, that is equal to uh, full integration total 0 to t, that is sine twice omega t dt by t. Okay, so this full length, okay, that's 0 to this length is t. Okay, the full cycle, so that is 1 by t. Okay, so that is equal to 0 to t sine 2 omega t means minus cos twice omega t by twice omega, integration limit 0 to t. Here 1 by t, so also 2 omega here. Okay, constant. So cos 2 omega capital T minus cos 0. Okay, cos 0, 0 into something, 2 omega times 0, so you get a 0 minus twice omega t. So cos 2 omega t means cos 2 omega equal to 2 pi by capital T times t, cos 0 being 1. So that is equal to minus 1 by twice omega t. So t will be the cancel, cos 4 pi. Okay, cos 0 be the 1, so cos graph is look like this. Cos 0 be the 1, cos pi by 2 be the 0, that is a pi, that is a 3 pi by 2 here, that is a 2 pi. So here cos 2 pi also get 1, so that's a if even number 2 pi 1, so 4 pi obviously be the 1, so 1 minus 1, that is equal to 0 into something, we get 0 here. So full cycle integration sine or cos. Okay. So here final conclusion is the full cycle integral of sine or cos result being 0. Okay. So total power 0 into whole, that is 0 watt. The total average power is 0 watt. Now we understand from with some diagram, with the help of some diagram, understanding the when the coil is magnetized or demagnetized, depending on the current for the diagram. Okay, so now the figure number 1 diagram with calculate power here. So there is a the material here. So now here is that called north pole, that's the south pole. Now the where it look like this. Now place a coil here and material inside and come passing through the coil, either magnetize or demagnetize. Okay, so if current in that direction is towards in that direction. Okay, so now okay, the inside and here is field outside from from south pole. Here there's a north pole, there's a south pole. So here, so current increase, these are the current. Okay, so current increase, keep in mind, current increases here. If current increase 0 to max value, if current increase 0 to max value, so the flux line are also set up. So these are the flux line. Okay, these are the flux line also set up, and so the core being magnetized. So flux line are set up. So flux line are set up and core being magnetized. So core being magnetized. So if core being magnetized, okay. So now the diagram is look like this. Okay. If now power diagram. So here these are the voltage. From like starting from voltage. These are the voltage point. Okay. So from voltage starting from here. These are the voltage and the current 0 to max value. So 0 to max value is look like this. 0 to max value here. These are the represent the current I. And here if current 0 to max value, there's a 0 to maximum value current here, so core being magnetized, so voltage and current both are positive, so the power will look like this. Power obviously be the positive here. There is a current, so here the power be positive at that point. Okay, these are the power here, these are the power being positive. Now in next diagram, in same diagram obviously. Okay, now copy the diagram. Same diagram. Okay, but here is the current is positive but decreasing. Here current also positive but decreasing order. Current also positive, but here current also positive. Here is 0 to max, here is decreasing. So if current is decreasing, so core is demagnetized. So core is demagnetized. So now that arrow being changed. So the core is demagnetized, arrow being changed. Okay. Okay. So this arrow being changed here. Okay. This arrow clear diagram here. Understand? Look like this. Okay. So core being demagnetized. So current here, see the diagram is decreasing, means falling. And here voltage also in here, voltage also negative. So voltage negative, current also decreasing. So there is a demagnetize. Okay. So demagnetize means this power V into I, there is a negative direction. If any one of these is negative, so plus or minus, if I multiply plus minus, we get minus. Okay. From mathematically. So the power is negative here. So power is negative here. These are the power here being negative. So here is the concept is, if core current is decreasing order but in same direction, so core get demagnetized. So core get demagnetized. Okay. Now name next diagram. Okay. So current in opposite direction. So figure number 3 here. So okay, current in opposite direction here, that's the figure number 3. So current in opposite direction, okay, but increasing order. Current in opposite direction. So here current is opposite direction, opposite uh, direction means from figure 1 we just so in negative direction. Okay, there is a negative direction. Okay, but increasing, but increasing. Okay, so here, so core obviously get magnetized. So here core is magnetized. Okay, and see that the diagram represents current is decreasing in negative. Sorry, current is increasing in negative direction. Current is increasing in negative direction. Current is increasing in negative direction. Current is increasing. Okay, here, but in negative current in opposite direction, but increasing. So here potential now at that point here V. So here voltage and current both are negative. So minus times minus, or minus multiplied by minus, we get plus. So here power is positive here. Okay. So power means core is magnetized. So power here positive. So now here, so fluxes look like this. There's a south pole, there's a north pole, and there's a field line here. Okay. Now, if the current is decreasing max to 0, okay, here is the same diagram. Okay, there's a south and there's a north. So okay, so here current is decreasing. Okay, from max to 0 in negative to positive direction here. Okay, so current is decreasing. Here, current is decreasing. Okay, from max to 0 here. From max to 0. Okay, and so max to 0. So core being demagnetized here. Sorry, the arrows look like, so core being demagnetized. So core get demagnetized. So core demagnetized. Why? Because that voltage now in positive reaction. The plus minus, we get result is minus. So that's why core is demagnetized. So here power, these are the power, that power is minus here. That blue line represent current and the red line represent potential. Okay, that's the diagram. Clear? Which there's a 4 figure, figure 1, figure 2, figure 3 and this figure 4, and there's a graphical representation. Okay, so next class we discuss AC voltage applied on capacitor. So if you have any doubt, please ask in comment section. I will try to give the answer. Okay, so today end the class here. Thank you.